Hello everyone, my name is Zhiying. Okay, today I want to, my topic is long distance migration and homing after displacement in the green turtle, coronavirus, a satellite tracking study. Okay, so let's meet our main character, green turtle. Green turtle, which can grow to 1.5 meters long, and its average weight is 68 to 190 kg, and it's a herbivorous animal. That means it can just eat the sea grasses and algae. Okay, this is the reason that make it have a green fat under its carapace. Carapace means the hard shell of the turtle. Okay, right here. Okay, so and the green fat is the reason that it has been called green turtle. Okay. Actually, here is an island and here is a turtle. That my emoji has gone already, so I'm so sorry. So let's see this big picture. Okay, so here is the turtle egg. The turtle will hatching, then become a baby turtle, right? Okay, so the baby turtle will leave the nesting site to the feeding site. Okay, and it grow up. After it sexually mature, okay, if it is a female turtle, then it will come back to the nesting site as it hatching, the same place of it hatching. Okay, so it will mating with another turtle, male turtle. After mating, the female turtle will go to the beach and laying their eggs. Okay, after laying their eggs, the female turtle will come back to the same place, same feeding site. Okay. Oh, my turtle come out already. Oh, okay. Okay, okay. Okay, go to the nesting site, see, okay, lay egg. Oh, good. The emoji didn't go. Okay, back to the feeding site. Okay, so the distance between the nesting site and the feeding site can up to 2,600 kilometers. Very far, you know, this is a huge distance. Okay, so how the turtle make it? This is our topic today. We want to know the navigation mechanism of the green turtle. And does the turtle have the ability to pinpoint distant targets and home after displacement? Displacement means change the location. Okay, that means we want to change the location of the turtle. Then we just see it can come back to the same place or not. Okay, actually human beings so boring. Okay, so what to do? We need to track the green turtle long distance migration to the feeding site and the their straightness. Okay, so another thing is we want to do is change the location from their usual routes. So we need to do two experiments. Experiment 1 is do for the displacement. Then we need to do 2 times, first displacement and second displacement. Another experiment is to do for the migration trip to feeding ground. So here is the materials and method. We do the research when summer of 1994. I haven't given birth, you know. Okay. So here's a location, Cakapudang Beach. Cakapudang Beach is located at Terengganu. Terengganu is a city of Malaysia, my hometown. I come from Malaysia. And beside Terengganu, there's a small little island called Pulau Redang. In Pulau in Malay is called, means island, and Redang just a name, nothing. So here is the Pulau Redang, and here is the Cakapudang Beach located at the Cakapudang Beach. Here are very many green turtles. Okay, so here is the first experiment, displacement. Okay, don't forget we need to do 2 times. First, we need a female green turtle, okay, who come to laying egg. Okay, come to the egg, haven't laying. Then we need a rod recording device and a PTT, platform transmitter terminal. For rod recording is for first displacement, and the platform transmitter terminal is for second displacement. Okay. So here's the distinction between rod recording device and platform transmitter. Okay, rod recording device is something just like can record the angle of the turtle body axis. So if the turtle turns about 45 degrees south or 45 degrees west, then you can know it. Okay, the data will store in the digital memory card of this device. So you need to recollect the device. You need to recollect the device and take the memory card out. Then you can get the data. And how we attach it to the carapace, the hard shell of the turtle, is just used with a waterproof case. Okay, close the device and we can attach it. Okay, the platform transmitter terminal (PTT) is such as a GPS. Okay, so when the turtle comes to the surface of the sea surface, then we can get the signal from the satellite. Okay, so you just use your computer at your office. Okay, then you can get the data. No need to recollect this PTT. Okay, so we just attach it to the carapace with by using the marine epoxy. Epoxy is just like a quick dry glue. Okay, you know, super glue, something like that. Okay, first experiment, first displacement. Okay, we need a turtle who come to laying eggs. Okay, then we catch the turtle, or don't let it catch it. Okay, then we put a rod recording device on it. Okay, after that, the turtle cannot nest already because we catch it. Then we make a displacement for it. We bring the turtle to far away from the Chakahudang beach, 11.1 km. Okay, after that, let's see the result. The turtle was so brilliant. It came back to Chakahudang beach, very brilliant. Okay, so when we found it at the night of the next day, then we collect the device. Okay, collect the rod recording device back, then take the data. Then we found it has arrived at the morning of the day. Okay, so it just spent about 9 hours and 23 minutes only. Okay, then we make a second experiment. Now the turtle egg come back to Chakahudang, right? Okay, so it go to nesting already. It laying egg already. Okay, after laying egg, then we say, hey, don't go. Then we put another device, PTT, on it. Then we make another displacement. This time displacement is more further. Okay, about 284 km. You see, human being really so cruel, you know. Okay, then we release it. So let's see the result. Okay, result is the turtle come back to the Chakahudang again. Wow, you know Annabelle, right? The movie, just like Annabelle. Then when we throw it, then she come back again. So terrible. Okay, so we see the data, the total span. Okay, is about 7 days, 1 week. Then she can swim for 200 to 300 kilometers. Very far. Okay, so brilliant. Okay, but the turtle just wander for 5 days. Then she come to the Chakahudang and nest again. This is a second time. Okay, let's see the second experiment about migratory trip to feeding ground. This time we need 4 green turtle after nesting. Okay, they have nesting already, laying their eggs already. Then they want to come back to their feeding site, their home. Okay, then we say, hey, don't go. Then we put this PTT on 4 of them. Okay, then we need to calculate this straightness index. So what is straightness index? Okay, you can see here is a straight line, right? Red color straight line. Okay, but the turtle won't swim as a straight line. It will swim with a curved path. Okay, so the ratio between the straight line and the curved path is the straightness index. If the straightness index is close to 1, that means the turtle swim very straight swim. Means the turtle very clearly where the destination she want to go. So she will swim very straight. If the index is not close to 1, that means the turtle swim in a very curved path. She so wonder, left hand side, right hand side, left hand side, something like that. Okay. So we see a result. For the turtle A, she back to the feeding site, swim cross over the South China Sea, then reach Sabah. Okay, for turtle B, also swim across the South China Sea and reach the Busok Islands of Philippines. Okay, then their straightness index is quite close to 1, right? So that means that they swim very a bit straight. Okay. Then for turtle C, also she came back to its feeding site at Pangkat Islands. And for turtle D, she also swim. Why she stopped here? Okay, so we just predict she is heading to Timberland Islands. Here is a small little island over here. Okay, so we predict only she is heading to Timberland Islands. So let's see the straightness index. Both of them also quite close to 1. But why turtle D have a short distance and short time? It's because the emission stopped already. The emission stopped at here. So we didn't receive any signal from the PTT. Maybe the PTT have dropped, or maybe the turtle has been eaten by shark or what. Okay, so we didn't receive the signal. So the data is quite short. Okay. Let's discuss about experiment. The turtle has been displaced for 2 times, then come back like Annabelle 1. Okay. Then we found it's so successful. Okay, wherever we put it, then she come back again. Okay, very clever. Okay, so we see that speculative index about 4 turtle back to their feeding ground, mostly close to 1. Okay, what the meaning? It is because the turtle have the ability to pinpoint distant target and honk after displacement. Okay, they are so clearly where's the destination, then where you put them, they can go back to the same place. Okay, very brilliant. Okay, so make it. So how about the true navigational mechanism? We can find that the turtle C straightness index is not quite close to 1. Okay, it's because the turtle C back to the feeding site use coastline as a ground, as a guide. You see, this is the coastline. Okay, and for turtle A have the same appearance. Okay, use the coastline here. Okay, but how about the long distance for turtle A and B who get back to their feeding site? Okay, here is a very long distance, right? Okay, South China Sea is a quite shallow water. Maybe the turtle should follow the shore features under the water. Shore feature is just like a bar, port, reach, runner, or something like that. Okay, maybe the turtle follow them to go back their feeding site. But in previous report, we found that turtle can swim in very deep water, and part of turtle A and B swim in the deep water. Here's the very deep water one, got the sea canyon. Okay, so if the water is very deep, turtle can't even see what is under the ocean. So there is nothing to follow. Okay, so we think that use the coastline and shore features is not the only mechanism. There is another reason for the turtle to come back their feeding site. Okay. So we discussed it. Using stars at night, maybe a turtle watch the star and swim. But we found that turtle eyes are very poor out of the water. They even cannot see you. So how can they see the stars?
Okay, 12 minutes. Go to conclusion.
Here, our conclusion is turtles have ability to pinpoint distant targets and honk after displacement, and the true navigation mechanism of turtle is still a mystery. Okay, here's our report. Thank you.
Sam. Sawyer. Chris. Charlie. Hands on. Okay. Sam.
So they only catch one turtle to the first excursion?
Yes. I think the reason is because the turtle is quite a special species. So if we did more experiment for turtle, then some people will say something because it is quite cruel or what. So, but actually I think one turtle is quite enough because the turtle is in twice of the displacement is quite successful. So I think that if one turtle is quite enough lah.
Chris.
So you're talking about the PTT. So PTT got the location data from GPS, right?
Something like GPS.
So when the turtle swim under the surface, well, they get the signal, and if they don't get the signal, how the straightness index will be accurate?
Okay, actually the straightness index might be actually like fixed, every fixed. That means the data from the PTT. But the PTT must collect the signal. The turtle must be came up to the surface of the sea. Then the PTT gone out, then send the signal to the satellite. Then we can receive the data. Okay. So if the turtle is under the deep ocean, then we cannot know their specific position. But if they come up, then we cannot. But turtle is quite frequency to come out because the turtle need to exchange the egg.
Charlie.
Do they back to the feed site with the same road when the place they?
Okay, I know your question.
What is his question?
he said it's the same place, same feeding site or not, right? Feeding site or feeding site. Okay. So actually, this paper just did for one time about the turtle came back from the nesting site to the feeding site one time only. So we just know this is the feeding site of the turtle. Why we thought this is the significantly feeding site of the turtle, because we do this experiment, we get the data over here. But the emission, okay, just for turtle, okay, we see turtle C, okay. We know that she reached the place in time of 27 days, right? But the emission didn't stop. We just calculate the emission about 2 months. So we are so confirmed that is a feeding site of the turtle because she located at here 2 months. Okay, will vacation to a place 2 months is too long, right? So we ensure that this is the correct feeding site of the turtle. Okay.
Enzo.
Like the male turtle, they don't need to lay the egg. So, but do they have the same system to travel for the long range?
Okay. Yes, the male turtle also will travel from the nesting site to the feeding site also. But the turtle can the nesting site every year. You know, okay, the female just come 2 to 4 years back to the feeding site. The female will come the nesting site every 2 to 4 years, but male will come every year, okay? It will go migration also, but I'm not sure the feeding site of the male turtle will be quite far or quite near, I'm not sure, but I know the turtle will come every year, so I think they will do migration also. They won't live at the nesting site, they come and go, come and go, come and go. Just like a hospital, you know, come and nest and go, come and nest and go.
Volunteer question, any? Volunteer question? No?
Teacher?
Go on. Go on.
Can I know what is the other mechanism that the turtle travel back?
Okay. Just now I didn't have enough time to say this question. Okay. Here's the prediction on it. Okay, predict on it using stars. Then we perfect cannot because the turtle cannot see the stars, so they cannot follow the stars. North here, south there cannot. Then Earth magnetic field, Aldous gradient. Aldous gradient means the smell from the target. I think it's so quite hard because the target is so far, so cannot smell. Then the low frequency sound from the waves breaking on the rocky shore. This is quite hard too because the target is so far, about 2,000 kilometers. So I think both of these is quite hard. Then in this paper, because my paper is 1994, quite long already. But for now, 2019, we have a result already. Okay, this is the true navigation system for the turtle using the wave direction, sunlight, and temperatures, and the turtle will imprint on the magnetic field of the beach. So they will detect the magnetic information by using their magnetic forecasting on the magnetic crystal in their brain. In their brain, they have the magnetic crystal, so they can note the whole of magnetic field. Then, like a compass, like a GPS, the total equal to the GPS. So they know where they are and they know where they should go.
Okay, so I think you would agree with me that it's a very enjoyable talk, and there are several strengths of her talk, like her stage performance was really brilliant. She was looking at you all the times, and she talked with up and downs, so you feel that you are like a really with her tone, and then she also used a lot of body language, and then she tried to make. She also, her talk was quite humorous, and she talked about these poor turtles, poor human beings, and then she humanized the research subject. These are the skills we have been talking about many times, and I saw that she has used basically all the skills. If I'm going to criticize her talk, the only weakness was she was really talking fast. Okay, because she has a lot to say, so you can see that even at 12 minutes she couldn't finish the talk. And my comments would be some of these discussions, like regarding uncertainty of the navigation systems, can be taken out, because these are in this scope of this study, it's all speculative. And if you really want to give us something that's impressive, you can just jump to the 2006 finding and tell us, okay, what has been known. That would be fine. Then you go to your conclusion quickly and focus on what has been found. Mainly that the turtle can come back always, and then the route is really straight. That's the key finding. Then you conclude this talk. And you can see that her talk has a lot of animations, and which are actually quite nice, because with this animation you have the feeling that it's an active process instead of just the line. It's the route of a turtle. Okay. And then the way she presented the straightness index is also perfect. She said, what does one mean? One means straight. Okay, so overall I think it's a really good talk. The only weakness is too long. Okay, so let's thank Zhiying.